What if I told you that the deadliest weapon in human history, the machine responsible for shaping empires, winning wars, and committing the darkest atrocities, was invented entirely by accident? And what if I told you the people who invented it weren't trying to kill anyone at all? In fact, they were desperately searching for the exact opposite. They were looking for the secret to eternal life, but instead of an elixir of immortality, they unleashed a chemical demon that would eventually paint the entire earth in blood. This is the dark, bizarre, and twisted evolution of the gun. How did humans go from mixing strange powders in a secluded cave to engineering precision-killing machines that can end a life from a mile away? The answer is hiding in the chemistry. Let's pull the trigger. Our mystery begins in 9th century China, during the height of the Tang Dynasty. It was an era of profound scientific discovery, but also an era obsessed with the supernatural. Chinese alchemists, heavily influenced by Taoist philosophy, were on a relentless quest. They believed that by combining specific, rare earth elements, they could create a potion, an elixir, that would cure all diseases, stop the aging process, and allow the emperor to live forever. These alchemists weren't soldiers, they were monks, scholars, and early chemists. They spent decades mixing strange and often highly toxic recipes. They consumed heavy metals, drank potions laced with gold, and experimented with honey, realgar, and arsenic. But out of thousands of failed experiments, one specific, highly volatile formula caught their attention. It consisted of 3 seemingly harmless ingredients. The first was saltpeter, also known as potassium nitrate, a white, crystalline substance often found in caves or scraped from the walls of old latrines. The second was sulfur, a pungent yellow mineral that smelled like rotten eggs. And the third was simple, everyday charcoal. From a modern scientific perspective, this mixture is an absolute nightmare waiting to happen. The charcoal acts as the primary fuel source. The sulfur lowers the temperature required to ignite that fuel. And the saltpeter, that is the ultimate oxidizer. It forces the fire to burn incredibly fast, releasing a massive amount of expanding gas and heat in a fraction of a second. When the alchemists combined these 3 ingredients, usually in a ratio of about 75% saltpeter, 15% charcoal, and 10% sulfur, and exposed it to a flame, it didn't grant them eternal life. Instead, it violently exploded. It burned down their laboratories, singed their skin, and caused severe, catastrophic burns. In early Chinese medical texts from the year 850 AD, scholars wrote terrified warnings about this mixture, explicitly telling others not to experiment with it because it had caused entire houses to burn to the ground. Ironically, because it was invented by medical researchers, they gave this terrifying new compound a rather misleading name. They called it Huo Yao, which directly translates to flaming medicine. But it didn't take long for the military generals of the Tang Dynasty to realize something crucial. This so-called medicine wasn't meant for healing, it was meant for destruction. For the first few hundred years after its discovery, gunpowder wasn't used to shoot projectiles. The concept of a gun didn't exist yet. Instead, the Chinese military used it for psychological warfare. They tied small packets of the powder to the ends of arrows to create incendiary weapons, and they built loud, terrifying fireworks to spook enemy horses. But in the 10th century, as conflicts intensified with neighboring nomadic tribes, military engineers had a truly sinister, psychopathic idea. They realized that the most destructive part of gunpowder wasn't just the fire, it was the rapidly expanding gas. If you trap that gas in a tight space, the pressure builds up until it violently rips its container apart. So, what if you packed this exploding powder into a hollow, thick bamboo tube? What if you added some sharp rocks, broken pieces of pottery, and rusted metal scraps? And what if you lit it on fire while pointing it directly at another human being? By the late 1200s, during the Yuan dynasty, metal workers stepped in to solve the bamboo problem. They upgraded the weapon from flimsy wood to heavy cast bronze and iron. They made the tube incredibly thick to withstand the internal pressure, completely sealed off the back end, and left a tiny hole, a touch hole, just big enough to insert a fuse. Then they made the most critical leap in the history of warfare. Instead of filling the tube with random bits of gravel and glass, they dropped a perfectly fitted, solid round stone or metal ball inside. Now, the trapped, expanding gas from the exploding powder had only one single way to escape: out the front of the metal barrel. And as that massive wave of pressure rushed forward, it violently pushed the solid projectile out with it at fatal, unprecedented speeds. The first true gun, the hand cannon, was born. These early hand cannons were brutal, heavy, and awkward to use. A soldier had to hold the heavy metal tube under one arm, aim it roughly at the enemy, and use his other hand to press a red-hot coal or a slow-burning match directly into the touch hole. It was inaccurate, slow to reload, and incredibly dangerous. But when it hit a target, the results were devastating. Armor that had protected knights and soldiers for centuries was suddenly entirely useless. A lead ball fired from a hand cannon could punch straight through steel plates, shattering bones and destroying organs in a way that swords and arrows simply couldn't. But how did this heavy, dangerous prototype make it out of China to become the weapon of choice for the modern world? You can thank the deadliest and most efficient delivery service in human history, the Mongol Empire. As Genghis Khan and his successors ruthlessly conquered their way across Asia, the Middle East, and all the way to the borders of Eastern Europe, they absorbed the technologies of the people they defeated. They took the Chinese hand cannons and the secret recipe for gunpowder and brought them on their devastating cavalry campaigns. By the time the smoke cleared in the 1300s, the secret of the flaming medicine had reached the battlefields of Europe. And the Europeans, they weren't just going to use this crude metal tube. They were going to obsess over it. They were about to take this basic chemical reaction and merge it with advanced clockwork engineering to create the first true mechanical sniper rifles. The era of the sword was officially dead. The age of the trigger was about to begin. When the crude, heavy hand cannons finally reached Europe in the 14th century, they were terrifying, but they were deeply flawed. You are a soldier on a chaotic, muddy battlefield. You are holding a heavy iron tube under one arm. In your other hand, you have a burning, red-hot piece of coal or a smoldering rope. You have to look at your enemy, look down at the tiny hole on your gun, press the fire against the hole, and pray that it doesn't blow your own fingers off. It was virtually impossible to aim. You couldn't look down the barrel. The Europeans realized that if they wanted to turn this explosive stick into a precision weapon, they needed to free up the soldiers' hands. They needed a mechanism, and to get it, they borrowed technology from the most unlikely group of people on the planet: clockmakers. In the mid-1400s, European engineers introduced the matchlock. This was the first true mechanical trigger in human history. It was shockingly simple, but brilliantly effective. They attached an S-shaped piece of metal, called a serpentine, to the side of the gun. This metal arm held a piece of slow-burning rope soaked in potassium nitrate. When the soldier pulled a small lever at the bottom of the gun, internal clockwork springs snapped the metal arm downward, plunging the burning rope directly into a small pan of gunpowder. Boom! For the first time ever, a shooter could keep both hands firmly on the weapon. They could press the gun against their cheek, look straight down the barrel, track a moving target, and fire. The matchlock changed the entire psychology and sociology of war. Before this, to be a lethal force on the battlefield, you had to be a knight. You needed decades of expensive training to master the sword and the longbow. But with a matchlock, a peasant who had been farming dirt for 20 years could be trained in just 2 weeks to pull a lever and kill a heavily armored aristocrat from 50 yards away. The gun was no longer just a weapon, it was the ultimate equalizer. But the matchlock had a fatal weakness: the weather. If it rained, the burning rope went out. If it was too windy, the flash powder blew away. In the dark, the glowing ember of the rope gave away your exact position to the enemy. The weapon needed to generate its own fire, on demand, entirely in the blink of an eye. Enter the flintlock in the early 1600s. Instead of a burning rope, the trigger mechanism now held a sharp piece of flint rock. When you pulled the trigger, the flint violently struck a piece of steel, showering a cascade of white-hot sparks directly into the gunpowder. It was reliable, weather-resistant, and instantaneous. The flintlock became the signature weapon of empires, pirates, and revolutionaries. It built the British Empire and won the American Revolution. But even with the flintlock, guns were still smoothbore. The inside of the barrel was perfectly smooth, like a pipe. When the round lead ball was fired, it violently bounced around inside the metal tube before exiting. It was like throwing a baseball with zero spin. It tumbled erratically through the air. Beyond 100 yards, hitting a specific target was pure luck. To fix this, gunsmiths perfected rifling. They carved deep spiral grooves into the inside of the barrel. When the bullet was fired, these grooves tightly gripped the soft lead, forcing it to violently spin as it traveled down the tube. Just like a perfectly thrown football, the spinning bullet cut through the air with terrifying aerodynamic stability. Suddenly, soldiers weren't just firing blindly into crowds, they were sniping. They were picking off enemy generals from hundreds of yards away. The killing became calculated, precise. As the 19th century rolled in, the gun was about to take its final, most devastating biological leap. For nearly 1,000 years, from the Chinese alchemists to the American Civil War, loading a gun required an agonizing multi-step process. You had to pour black powder down the muzzle. Then you had to wrap a bullet in a patch of cloth and ram it down the barrel with a stick. Then you had to place a separate ignition source on the outside of the gun. It was slow. Even the best soldiers in the world could only fire maybe 3 to 4 times a minute. A minute is an absolute eternity in a firefight. The Industrial Revolution looked at this slow process and decided to package death into a single, highly efficient consumer product. They invented the metallic brass cartridge. This is the bullet as we know it today. Engineers realized they could put the primer, a highly sensitive impact explosive, at the bottom of a brass cup. They poured the gunpowder directly inside the cup and tightly sealed the top with the lead bullet itself. The spark, the fuel, and the projectile were now unified into one waterproof, perfectly sealed, self-contained unit. You didn't need to pour powder anymore. You just slammed a brass shell into the back of the gun, pulled the trigger, and a mechanical firing pin would smash into the primer, detonating the entire package from the inside out. The brass casing was the missing puzzle piece. Because brass expands when it gets hot, the moment the gun fired, the brass shell swelled up, perfectly sealing the back of the gun so no gas could escape. All the explosive energy was forced forward. This single invention triggered an avalanche of mechanical slaughter. Because you no longer had to load from the front, engineers could build guns that loaded from the back. They built lever-action rifles that could fire 15 rounds in seconds. They built the Gatling gun. And eventually, they built the Maxim gun, the first true, fully automatic machine gun, capable of firing 600 rounds a minute. Let's rewind the clock. Think back to that damp, isolated cave in 9th century China. Think about the monks and the scholars sitting around a bronze pot, meticulously mixing sulfur, charcoal, and saltpeter. They were so desperate to find a way to preserve human life. They were looking for immortality. They wanted to cure death. Instead, they democratized it. They set off a chain reaction of human engineering that transformed a simple chemical fire into a precision machine capable of ending a human life from miles away, in fractions of a second. The evolution of the gun isn't just a story about metal and chemistry. It is a chilling mirror reflecting our own nature, a testament to human ingenuity and our brilliant, terrifying ability to engineer our own destruction.